right, I'm starting with physics today. Physics. So I've done some thinking and I've done some planning and I've done some reading through the book. And I have made an executive decision, and we're not going to do the second section to chapter 13. There's really not much in it at all anyway. And it's not anything you're ever going to use really again. So, and it really was just 3 formulas and plugging the numbers in the formula. So we're not going to bother with it. We're going to stop where we are. We are going to do a test on Friday, like I had said. We will do a test on Friday, which gives you from Tuesday to Friday to be asking questions if you need to. We will do it via Zoom because there is some theory on it, not very much though. Really, when we talk about what theory is on this, we talked a little bit about some terms: periodic motion, simple harmonic motion, those types of things. We talked about, excuse me, we talked about, really, then we talked about pendulums, and we talked about, there were 2 things that you had to take into account, like when you're dealing with a pendulum, the angle can't be any more than 15 degrees, and there was one more thing, I'm trying to think of it, and the mass of the pendulum pole, we don't use that. We just use the mass of the pendulum. We look at the mass of the pendulum itself, but the angle has to be less than 15 degrees, and the mass of the pendulum pole is negligible. So the thing that the pendulum is hanging on, we ignore the mass of that entirely. Really, that's it. There's not a lot of theory in here, so there's not much of that. There's more math in this one. And we talked about a couple of formulas. Again, one that had to do with a mass on a spring, and we said period is 2 pi times the square root of m over k. But we also use the kinetic energy formula and the elastic potential energy formula. And then when we were talking about pendulums, the formula for pendulum was period is 2 pi times the square root of L over G. Those really were the 2 things that we did. Now I went back through the homework. I haven't marked it yet. I haven't gone through and really looked at your stuff. So if you're screwing something up and you haven't checked the answers at the back of the book, I don't know that. But I did get a question about number 4 because I'm not sure that the answer at the back of the book is clear or even right. So I did get a question on number 4, and I got several questions on number 7. So those are the 2 I'm going to do. Someone said that they thought that the answers at the back of the book must be wrong, or else they were getting a lot wrong. I didn't make any notes, and I usually make notes if they're wrong at the back of the book. I don't think that they are. But we're going to look at number 4, and that is on page 608. And then we're going to look at number 7, which is further on. And that will be it. Again, you're going to have a test on Friday. I am also this week, probably within the next 24 hours, if I haven't already done it, is I will be uploading your year-end project. Your year-end project is taking the place of your exam, all right? So there will be questions on there. It's all going to be the math part. There will be questions on there. You will have to, like any other assignment from me, you can use your textbook, you can use your notes, you can use each other. If you have questions about a type of question, I will answer that. I will not do the specific question on the assignment. You will have until June 5th to hand that in. That's the last day of classes. We're not going to learn anything new. So really, this will be it. All right. So today is honestly the last day that I will be going over anything unless someone asks for something. Okay. So number 4 on page 608, the maximum speed of a 1.5 kilogram block, so mass is 1.45 kilogram. The maximum velocity is 0.84 meters per second. And if the amplitude of the oscillation is 12 centimeters, so that means it goes out, it extends out, I'm going to call that X, that it extends out to 12 centimeters, so 0.12 meters. They want to know what is the force constant of the spring, so they want to know what's K, and they want to know what is the period of the motion. So if this were me, and it is, the first thing I would think about is that my maximum velocity, where's my little, there it is. My maximum velocity happens at like the middle point, right? Like it's here, it stretches out, it comes back in, and it compresses, and then it goes back. So it's going in and out. So the maximum speed happens right here in the middle. So the maximum speed happens right here in the middle. And that is when your total energy is all kinetic energy. Because at that point, this is not stretched out any and it's not compressed any. So there's no elastic potential energy. So all of the energy is kinetic energy. So I would say then that my kinetic energy is equal to 1/2 mv squared. So that would be 1/2 my mass, which is 1.45, times my velocity squared. And so my total kinetic energy, somewhere I left Harriet, my total kinetic energy would be, there she is, my total kinetic energy would be 0.84 squared times 1.45 times 0.5, that is 0.51156. That is my kinetic energy. It is the total amount of energy at any given point. It's just at this point, the total energy is the kinetic energy. Now, if I stretch it out to 12 centimeters, that's at the end here. If I stretch it out 12 centimeters, at this point, all of the energy is elastic potential energy because it's stretched to its max, it's momentarily stopped, and then it will start coming back in. So at this point, my elastic potential energy would equal what my kinetic energy was here, right? Because, elastic potential energy is 1/2 kx squared. So my elastic potential energy would be 0.51156, and that is 1/2. K is what I'm trying to find. X is 0.12 squared. So I should now be able to figure out K. When I did it, I got 71. Let's see if I get that. Let's see if I get that now. So I would do 0.12 squared times 0.5, and then I would do 0.51156 divided by that answer. Yep, I get 71. I get that my K is 71. It's actually 71.05, but because I can only have two significant figures, 71. Then they want to know what is my period. Well, I have a formula for that. It's here. Period is 2 pi times the square root of my mass, which is 1.45, over K, which I just figured out is 71.05. So if I do 1.45 divided by 71.05, and I take the square root of that, and I multiply it by 2 pi, I get 0.897, which would round off to 0.90 seconds. So not quite 1 second, which makes sense with the question. So that's number 4. That's what I get for number 4. The other question that I got from a few people was number 7 in the section that dealt with pendulums. So if we look at that, number 7 says, if every swing of the pendulum in a clock causes the second hand to move at an angle representing exactly half a second, what must the length of the pendulum be to make the clock keep accurate time? So here is what I said. I said that, let me read it again. If every swing of the pendulum in a clock causes the second hand to move at an angle representing exactly 1/2 of a second. Okay, so there it is. So let's talk about what they're saying there. What they're saying is every swing. So there would be a swing, there would be a swing. So for it to go up, down, like for it to go through one full arc, that's actually 1 second, okay? Because it's got to go from however many degrees to however many degrees. So it's like that's a swing and that's a swing. So 1/2 a second and another 1/2 a second is what they're saying. So that is likely where you went wrong with that, because the period should actually be 1 second long, not 1/2 a second. I noticed in my notes I started off doing 1/2 a second and then realized what my problem was. And it really has to do with the wording of the question. If that's the case, the formula is period is equal to 2 pi times the square root of L over G. Now we are looking for L. That's what we want to know. So the period is 1. That's equal to 2 pi times the square root of L over G. Sorry, G is 9.81. And so I would divide both sides by 2 pi. So I would do 1 divided by 2 pi is the square root of L over 9.81. I would then square this side and square this side. And then I would multiply this side by 9.81 because I need those to cancel. So I would multiply this side by 9.81. So what I would end up doing is I would end up doing 1 divided by 2 pi. And I'm putting 2 pi in brackets just to be sure. And then I'm squaring that. And then I'm multiplying by 9.81. And I'm getting a length of 0.25 meters. So 25 centimeters. And that would be it. All right. So I don't really have anything else to say. We're going to do a test on Friday. Unless you want to do it earlier, you can. We could, if, you know, everybody piped up and said, I'd like to get it done and over with. Sure, we can. I don't care. Can't do it Wednesday because I'm doing a Math 11 test that day. So we couldn't do it Wednesday. So I set it for Friday. Just that it was separated a little bit from stuff. And that will be the last test you're going to do for me. The only other thing you're going to do for me is that big long assignment due June 5th. It's going to cover everything we have done from the last exam until now. I can't remember whether that's chapter 8 through 13 or 9 through 13, so I got to look back and see. And then I've got to compile some questions. I have it mostly done, but I've got to pick and choose some. And I will send that to you within the next 24 to 48 hours, I would say. You'll have that. Again, you'll have it until June 5th. The only thing I would say about that is please don't rush through it just to be done so you can say I'm done. This is going to affect your mark. Like it is going to be important that you do, your best on it. So don't just, whip off a bunch of answers, not really pay attention to what you're doing and hand it in just to say, "Phew, I'm done." I don't foresee a lot of you doing that. Most of you are really responsible and are going to put your best into it. And I need to tell you to calm down and not worry so much. So anyway, just, try and find a balance there. All right. I will talk to you again soon. Bye.